Alright, it should be recording. Better check. Yeah, well, it seems okay. Alright, yes, nothing in the comments section. I have watched a couple of videos. This rational science guy, Bill Gates, did do a rag on the Jeff Yee guy and, threw in his rope alternative. But the only thing good about the rational science guy, he does bring up words and the idea of understanding the difference between objects, things, describables, things you can draw, versus physics that doesn't have a mechanism, that just talks about a probability. It just happens. The space is bent, even though bending won't actually work in 3 dimensions. But that sort of gets to the point that the critique of conventional physics is kind of an easy one. I mean, everybody who has any kind of reasoning skills can see the vacuousness of the explanation. I mean, Newton saw water swirl. I mean, Newton knew what a bowl looked like. Newton could have suggested, well, gravity is bent stuff and stuff falls into the bending. He could have. I mean, doesn't take that much imagination. But I think he would have thought, well, that's not an explanation. How does the space get bent like a bowl? That doesn't make any sense. I have to explain why things are pulled in, okay, or pushed in. Those are the 2 choices here. And just saying bent space, that's saying nothing. It doesn't add any value. We already know the fact that it is a convergence. Now the question is it being pushed or is it being pulled? So Bill Gates goes with the pull answer, which in my opinion is another no-brainer in terms of figuring out that no matter, look, even if you have ropes tied to everything, then you have to have arms to pull on the ropes. You have to have mechanisms that twist the ropes. It's again, you're not going to find any of those mechanisms. You're not going to find a machinery that can do all that complex stuff. And in the end, we know that the basic elements of movement in the universe is all really elemental. It's all very simple. Things acquire a velocity, because something acts on it. We call that thing that acts on it a force. So Bill doesn't like the word energy or force because he thinks they can't be made out of anything. He thinks it's impossible, when of course it's not impossible. And obviously a pull would look just like a push if you just didn't see the thing getting pushed. I mean, if I was the invisible man and I could push people into other people, they might conclude, I was pulled into you. I don't know what happened. I was just minding my own business and all of a sudden I flew into you. And so they might conclude that there was some mechanism that pulled people together, when no, obviously just somebody pushed. And the key is that we don't see the fundamental forces. We don't see the photons, technically, in the sense that they're not, they're moving all over the place in this room, but I don't see any of them moving all over the place in the room. I only see the tiny number of them that go through my little tiny pupil. That's the only ones I know about. The rest of them are completely invisible. But they're all over the place. I'm moving my hand through them right now. And so, understanding that forces are things isn't a problem, that they're objects, they're made of something. The field is made of soldiers, or it's made of corn, or it's made of something. It's not nothing. So another thing I watched was a couple of lectures by a really, he's not a professional teacher. They're MIT lectures. And, it's just quite silly. So maybe I'll play some of that because it's quite silly. I don't know if I can I wish they would just link to the YouTube channel. I mean, they're using a YouTube embed, and so it makes everything the wrong size. I mean, obviously it's not a very good size. I don't know if I want to go full screen. It would be too much, right? Yeah, it's really full screen. I don't like that. Well, I guess I could live with it.
Only emerges after you allow a large number of photons to go into the apparatus.
So, a large number of photons. So he's talking about the single photons at a time part, but it gets, I just say, it's just the same mistakes being made over and over again. The same jargon that is kind of indefensible because it's just so wrong. Alright, so relating these things. Maybe we'll just play a little bit of Bill randomly, but he might say something about energy.
In the morning. And last time we spent 3 hours debating with Peter.
Okay, so he's talking to some French guy and blah, blah, blah. So he's going to do that again. So he won't talk to anybody else, but I guess he'll talk to some French guy who doesn't know anything about anything. How do we get on the wrong video? Oh, God, it's just so annoying. I hate this forward button. It's just always fucking me up. Alright, anyway. What do I want to do? Yeah, so the word energy. Bill is talking, oh, it's a concept. And other people have said energy is nothing. I think the whatever his name is, the Ulster guy, says it's not a real concept or a real thing. Of course it is. It's just imbalances in forces. So, energy... Yeah, if I take you on a trip to the moon, and you go, 80% of the way there, there's a point where the gravity of the moon will equal the gravity of the Earth at some location. So at some location, you'll have neither body will be affecting you gravitationally. Now, both are affecting you gravitationally, right? It's not like gravity stopped on the moon or gravity stopped on Earth. But you don't sense any force because there's no imbalance in the force. And so I've said this before, but energy, the energy is insane in its proportions that's out there. But you can only access it when you create imbalance. You can only access it when you take away something on one side and add on the other side. Either way, you have to take a system that's even and you have to make it uneven by subtracting or adding. And that's when we call it energy. So we call it energy when the raindrops fall. It was imbalance in temperature that drove the water up, and then its mass drives it down. And we call it energy when it's moving, but the fact is when they're just staying up in the sky, they have a balance. And we don't call it, it's not energy when they're up there doing nothing. It's only when they're either going up or they're going down that we call it energy. But it's still energy up there. We call it potential energy, but everything has a tremendous amount of potential energy. Then it's like all I have to do is, cold fusion or figure out some way to make the atoms just a few tiny number, few thousand, few million, whatever, a little speck of them, little tiny few one thread of the atoms on this sweater, and I make them explode. Then I'll have a huge imbalance on this side of me, and I'll be blown that way and in little tiny pieces. And we'll say, gee, that was a lot of energy. Well, it was a lot of imbalance. It just shows how much energy is in atoms. But I'm just saying that it's always, energy is just when energy is revealed. Okay, it's only when the power of the force, is only revealed in a circumstance of imbalance. And so another point to that is this idea of conservation of energy, which sort of means is like, this object thing. And even this gets to the wave thing of the two-slit experiment and how the energy goes. It doesn't hit where it's supposed to, it hits somewhere else. Because it has to go somewhere. You can't destroy this energy thing. You can only convert it into different forms. And some forms, like gravity, again, I've said this before over and over again, but you really have to understand how much light you'd have to hit this little object with for you to move it with the momentum that gravity is pushing it. And it gives you some appreciation. If you think about, well, I have to have a gigawatts of or a million watts anyway, of energy in the form of light to move this pen just a foot. And so it gives you some appreciation that that's how thick gravity is. It's a force, a bunch of soldiers. It's a huge number of them, but they're not identifiable because we can't see. Some soldiers don't wear hats and don't have little badges on their sleeves, and we can only see soldiers in a certain organization. So we can only see soldiers when they're moving at a perfect instep. We can only see them in certain circumstances, the electromagnetic spectrum. And even some parts of it we can't, we can see light with our eyes, we can detect it. And we can detect radio waves with receivers that are tuned to their specific frequency. And at the high end, you have to use other mechanisms, but it's a little easier in a sense because the higher frequency means they're more disruptive to things they hit, and so they'll make themselves known. But if they go a high enough frequency, you could argue they go right through us, like a cosmic ray. They just plow right through us. We don't even, I don't even know anything happened. But it's really probably also about size. So cosmic rays might only be 2 quanta of energy or 3 quanta of energy in that frequency. And if there's only 3, the electron won't be sustained in its being pressurized, and therefore won't eject. So if it was a trampoline, or something, you have to, a bow and arrow, you're going to pull the arrow back and then release it. So the idea is the arrow's pulled back by a ray of photon. See, this is so annoying because physics established this word photon for something with a frequency. They've sort of implied that the thing itself has a frequency, and that the thing itself isn't made of something that comes at a frequency. So I want to say photon, but clearly the photons we interpret, our brain receives, are the ones that affect electrons, and the only ones that can affect electrons have to hit them with enough energy at the right frequency. So it's like the ultraviolet thing. Now if you want to eject a photon from a surface, it'll probably fall back on again, but if you want to eject photons from metal, you hit them with ultraviolet light, and the electrons will pop off the surface and they'll fall back on again, but they'll pop off. And that was called the photoelectric effect. And but if you hit it with the white light or visible light, nothing happens. And you could hit it all day long with infrared light and you won't get anywhere. Well, you might get somewhere just by chance. A couple of rays hit, following each other real close, so 2 cars look like 1 car at the right frequency. But anyway, the whole thing is that there's all this energy hitting us. So I would argue that gravity is just these little rays, but they're too short. So with the bow and arrow example, to eject the electron, you have to pull the bow 4 notches back, or the arrow is going to go nowhere. It gets much stronger. That last bit is the real strong bit, right? So you sort of know that with a bow and arrow, is that the first pull gets you nowhere, right? And even the second pull back, that's lame. The arrow goes 10 feet and falls down. You want to really get the arrow to go somewhere, you got to pull it all the way back. And the same is true for the electron. You got to pressurize it all the way to make a long enough ray for us to detect it. So essentially the electron has to be hit back 4, and then when it comes back, it'll do exactly the same thing. It'll give back the photons in exactly the same fact that it will release the quanta of energy, okay, in the same ray-like manner of 4 elements. Now the 4 elements could be closer together or they could be further apart, depending on how much the bow has already been pulled back by you putting electricity into the system. See, I can put electricity into something and then hit it with photons, and I can create X-rays. I can create frequencies that are higher. So I can add energy to the photon by adding energy to the bow ahead of time, so you don't have to pull it back. So when you pull it back even farther and put more energy into it. So it goes faster, which means is it as it goes faster, it means it decelerates faster, ironically, because that's what the electron's going to do. It's going to decelerate, and on decelerating, that's when it's going to give back the photon. Maybe I could draw some of that. This is part of the reason I made this video, is because I can do such things. So let me. It was a test of this new drawing thingy. So the idea would be that a photon that we see, the pen doesn't work when I need it to. That's just such bullshit. Yeah. So the idea is that a photon has a minimum number of these little bits. If you don't have this minimum number, we can't detect it, because it's not going to. Strange, I drew it, but it's not there. Okay, so without this minimum number, and I'm just using 4 as an example, it could be 6, could be 10, could be 3. I don't think it could be 2. But without that minimum number, you're not going to be able to perturb an electron enough. That is, you're not going to, it can only give back what you give it, and it's not going to have enough energy to create it's not going to have enough dots to it to create something we can see. We can only see, it has to go in as a ray, or it has very little hope of coming out as a ray, except with the case of electricity. Obviously I can put electricity through a wire, and I can start heating the wire, and we'll get rays of light that are long enough, and that's because the electrons are being accelerated by the heat. They're being hit deep. As you make something hotter, see, the explanation would be, see, this has got so many parts to it. Alright, so the first thing I want to just point out is, so I could argue that gravity is little bits like this, and that cosmic rays are maybe even little bits like this. They're just not enough bits, and therefore it can't have the same effect. So this can go right through you without any effect, because it's not going to expel an electron, and it's not going to cause a rebound of the electron that will cause some higher energy. So you're just kind of stuck with that in bits that are too small. I could argue that a polarizing film takes, light that we can see, and it breaks it, because they're not perfectly aligned with each other. They're out of alignment. One of them hits one of the bars and gets knocked out, and then you end up with a half a photon and then another little bit, and so it can't be recognized by the electron, because again you're pulling the bow back 2 steps, and then the electron has time to go back 1 step, so you're lost any continuity. So anyway, all kinds of arrangements of this can be created, where you can end up having little stuff comes in and little stuff gets combined by the atom, and you can eject something more substantial. Alright, so I think it's very I think it explains how all this same thing, the same elemental force, can be made out of this one thing, and there's an explanation for why some of it's detectable and some of it's not. And the explanation has to do with this idea of pressurizing the electron. So I guess we'll just slide over here. Graph physics. It's my piece of paper, that's why that's on there. It's just indicating this is mine. Anyway, so I've sort of pointed out that, so the only good thing about this MIT guy is that he's not doing regular quantum mechanics. He is, but he's doing it from a chemistry point of view, which is more of an atomic point of view. So I might be able to glean something out of his conversation. This has a lot of Compton stuff in it, and he doesn't like doing math on the blackboard, so that's another good thing about him. But his performance skills are pretty bad. But anyway, it does get into this whole idea of I mean, you can clearly see he had some questions about whether these little bits are actually moving, and that they, in fact, might just be going back and forth, and that would do the same thing. But they're all stuck to this idea that any time the electron moves, that somehow it radiates, and it's not any movement. You know, they just say that a moving charge radiates a magnetic field. It's not true. I mean, the charges can move. It depends on how they're being moved. They obviously have to be in a system, and then they can release energy. So the idea is that these are all magnetically repulsive, as I've pointed out, the electrons. And so you don't need any orbital force to keep them from falling in to the proton. So they're attracted to the protons in the nucleus, but they're repelled by each other. And the repulsion to each other is enough to keep them from getting closer to each other. And so that's the resistance. And the idea would be is when the electron is compressed, it's moving into more pressure between its electrons. It's in a comfortable place when it starts, and you're sort of putting it in an uncomfortable place. You're pulling the bow back when you push the electron in. And the electron's going to be, by these forces, pushed back out. And as it is, as that other force hits it, it's going to release the energy. Now, getting this back to the energy argument and the conservation argument, I think something important, you know, when they talk about the two-slit experiment and the energy going to another location and all that, you can't destroy the energy. So if I take two things that are going a lot of speed, the idea is when they hit, you know, theoretically they could just both stop. I mean, this one hits this one, the two are opposite forces, and they just stop. But we know that doesn't happen in the real world, ever, realistically. And that if they do stop, there has to be somewhere for their energy to go. So the energy that was going this way has to go this way. And the energy that was going this way has to go this way. You have to account for where the energy went. So realistically, if two waves are crashing into each other, that is, one's going up and the other one's going down, right? And they're going to crash into each other and do destructive interference. Well, that means a bunch of these little atoms are going to stop moving. And why are they going to stop? Well, they're going to stop because that energy left. The energy was inside of them as a velocity, as momentum. And if they're going to be stopped, if they're going to be destructively interfere, if they're going to annihilate, they will have to release the energy that was in them, the momentum. The momentum goes somewhere. You can't kill a photon. You just can't do it. So the idea is the photon lives inside the objects that are moving. The energy is consumed, absorbed. It's made part of it. And that's that's the nature of inertia. Inertia is defined by how many little bits inside of you are moving the speed of light in a direction. And that defines, my hand is moving the speed of light, sort of, in the sense that the thing that makes it move is force moving the speed of light. Force shot up through my arm and you know, manipulated by all these cells and all this stuff to make these contractions in muscles and do all this kind of stuff to force this way, okay, to make it move. To stop it, the same thing, another force has to be applied, and the force is always conserved. It always goes somewhere. It never stops. So if something stops, if my hand is moving and it stops, well, that means some atoms gave up their directionality to the field. They gave it back to the universe, or they gave it to a neighbor and heated him up, or they did something else they're still somewhere in the system. The little bits just temporarily live inside of us. Okay, I mean, we're sitting here, and the little bits have gone into us in different directions inside of our atoms, and they're inside of us. And depending on how much, if we give away a bunch going this way, Well, then we're going to go that way, because we've equalized the pressure, and now it's just an argument about the simple math of how much is on this side and how much is on that side. And it's just, you know, this is the elemental function. It's just momentum in the form of these little force bits. And the force bits make gravity, and they make magnetism, and they make photons that we see. Everything in these spectrums and everything in these fields are real things with a little bit of momentum. And the momentum can get stuck on you or stuck in you, however you want to look at it. If you just thought of them as like little Velcro balls, the little Velcro balls can stick to you. And if more stick to you going one way, then, you know, you go that way. You know, blending that mass against your mass. So obviously you won't go there the speed of light. You'll go there depending on how much force hits you, divided by all the force that's already in you, and that balance will tell the school of fish which way it's going to go. So it really, but there needs to be, you know, me saying it. There needs to be a comparison between their theory and my theory, or Bill Gates and my theory. All of these people need to be able to examine each other's theories instead of just making proclamations. I mean, Bill Gates say no particle could do it. Well, of course they can do it, because it's just pressure. And then even somebody like Ken Wheeler, he says the word pressure, so he's getting something really fundamental, that this is all about pressure. But again, he thinks it's all made out of some sort of compressed and decompressed ether, and it's all perturbating and oscillating, and it's spinning, and it's doing all kinds of complex things that require energy. You know, like the D. Hilster guy, he's going to try to say that this stupid swirl energy is what's causing the attraction in magnets, and it just doesn't make any sense, because the swirl attraction and the swirl repulsion, Bill Gates says the same thing. He thinks it's swirling. Well, as I've pointed out, you'd need 1 billion times more energy in swirling stuff to get the attraction out of the magnet. So does it make any sense to you that there's really 1 billion times more energy than the attractive force in the swirling stuff? Well, then why don't we just tap the swirl? Why don't we just, you know, stick some windmills in the swirl, if there's so much energy in the swirl? You know, it just doesn't make any sense. I mean, it's just not very realistic. But anyway, there's just no conversation. It's the tragedy here. Alright, so, back to the videotape, I guess. Mouse, this one maybe. Alright, so we'll play a little bit of this.
Universe, and from other dissident groups like the John Chappell Society, all these.
So John Chappell Society doesn't even. So he's so fringe, you know, in terms of his associations. You know, he doesn't know it's Chappelle, you know, Chappell. You know, kind of hilarious. The thing is sort of irritating is he's done this video response to Jeff Lee's website essentially, and you know, I've been sending. You know, every couple of years I send Bill some sort of invitation to have a conversation, and I get nothing back. And I've watched, you know, 20 hours worth of his stuff over time probably, and I can't get nothing from him. You know, it's just kind of irritating.
Dissidents that they're opponents of mainstream, they're all in the same boat as far as I'm concerned. They're all mathematicians. They do.
Alright, so yeah, the real problem with, I would argue also, with Jeff Yee's wave theory is, first of all, it relies on the origin of energy being on the inside. So it's some little, they're basically little jellyfish. So there's these little nervy thingies, these little wave centers, I think he calls them, and you know, they're like my photons. They're the opposite version from the internal force idea. And they're just, you know, going like jellyfish all the time. And so you combine all these waves from the jellyfish. So when you make an atom, it has energy because the jellyfish are jellyfishing and making all this energy. And I think that's not very, it's not elemental enough, because you have a complex, weighty thing with no mechanism. And it also just creates all this waste. Like I said, the universe isn't that inefficient. Okay, the universe likely has a very efficient system of energy transfer, not an insanely inefficient one.
Physics, quotations physics. Other physics with...
Right, and they also, Jeff Yee originally called the particles of the universe, and so he was calling waves particles, little jellyfish. And it's really not fair to call waving stuff a particle, and yet conventional physics does it all the time. And, and that sort of gives Bill here license to sit there and rag on particle physics, when, no, particle physics can be rational. It doesn't have to be idiotic. It's just momentum. All that's happening in the universe is stuff is moving. When a thing moves from point A to point B, all right, it's going to do it with something called momentum. It has to. There's no, this whole idea of physics having these non-massive particles that do stuff is just retarded. Clearly, you have to have mass. You have to have substance. And mass just comes down to charge in some sense. So you can say, yes, there can be something that's not charged, but I don't believe there is. So the conversation's sort of moot.
Hazlehurst, I had it right. Okay, Jeff Hazlehurst, yeah.
So he's going back to the origin of Jeff Yee's stuff, which is sort of related to this whole wave stuff. So he has a little bit of an animation here.
And his name is Ray Tomes, and he's part of the same group of people, essentially.
Right, so these people who think this is how the universe works, I just don't understand how you think this is elemental. It looks really complicated to me, that somehow it knows how to do all of this stuff. How does it know how to do that, and why does it keep doing it, and all that other stuff? And, some people critique my theory and say, well, how does the photon move forever? Well, I don't know. It just does. But it's so simple to me, I don't know how you can miss it, in the sense that it's about as elemental as you can get for creating something called a force or energy. It's just to have something moving. And that's what it does. It moves. It just doesn't stop. It's just the way it is. And essentially it accounts for everything that's moving, because it has to push all the big stuff. But it's actually inside the big stuff too, so just in equal amounts in all directions. Alright, so this is his little energy spiel. Energy around us, everything around us is energy. So this is from Jeff Yee's site. Matter is energy, light is energy, heat is energy. In physics, energy is defined as the capacity or power to do work. Now again, work just has to do with something we see, that is, pushing something up, pushing something down, moving something left, moving something right. So work is just an obvious example of imbalance. Every bit of work, it just has to do with imbalance. You take the lead ball and you swing it and then you crash it into the building. It just has to do with creating imbalances. Such as the capacity to move an object by application of force. Right, and there is no magical force. There isn't something just called force. The force is made of real soldiers. There's real soldiers in the field. The force of your army. It's made out of something real. There is no force without the elements. Without the soldiers, there's no force. It's important to note that energy is neither created or destroyed, as far as we know. Understanding energy at its fundamental level and why these laws exist may be key to mankind's survival. But obviously, I don't think it's going to. It has nothing to do with mankind's anything. Key to mankind's anything is getting a grip on reality, and it seems like most humans find that repugnant.
You can't create it, and hopefully you can't destroy it. And understanding energy at its fundamental level and why these laws of science exist may be the key to mankind's survival. Again, shows that he's in line with Mr. Hazelhurst.
All right, so we'll jump ahead a little. I thought there's better rags he does on energy, but oh, here's a Feynman quote. So, Feynman says, it's important to realize that in physics today we have no knowledge of what energy is. So that's Feynman. It goes so much deeper than that. They have nothing as explanations for anything. So Feynman doesn't even believe in the wave theory, really. He just says there's probability built into the universe, that somehow the universe does roll dice, and somehow it knows how to roll dice, so everything comes out even in the end or something. You know, and these are all just nothing as explanations. So they don't have anything explaining magnetism. They have no mechanism for gravity that makes any sense. Again, you can't use this bent geometry crap because it doesn't explain how the thing is obliged to move. The geometry did it. It doesn't make any sense. There has to be some kind of force that's acting on the thing, and you know, they're just pretending. We don't need no forces. We don't need no stinking forces. Yeah, you do. So we'll see what Bill says here.
Information. You know, and in that sense, you know, no one's more of an expert than I am. I transferred information to the Cubans, to the Russians, to the Soviets, to China, to Iran, and I transferred information. So I know what transfer information is. But that's the...
I don't know what exactly he's talking about there, but I guess he's some kind of conspiracy theory nut or something, or he's worked for the CIA or something. I don't know what his thing is there. All right.
I was going to say, energy is part of his wave theory. Okay, so it's an important part of it.
So it says here, energy is the motion of the universe, ether, which travels as waves. You know, obviously, I think that's not a very good definition. So again, I'm just going to say that we don't have a word for the energy we don't experience. We don't have a word for it. If we can't see it move something, if we can't see the imbalance, you know, we're just assuming there's nothing happening, when everything is under extreme pressure. This thing, you know, we're under extreme pressure. And it's only because the pressure is being balanced that you know, we don't sense it, like we're weightless, but it's there, and it's intense, and it's what a nuclear bomb illustrates to you. The nuclear bomb is the anti-pressure bomb. It's the let all of the equalizing pressure that's inside of an atom. So an atom is so pressurized, you know, to equal the outside pressure. So to get equalized, to feel like it's weightless, it has to have an extreme amount of pressure inside of it, energy, little bits, pushing it, keeping it. So there has to be a ton of energy between the electrons to stop it from being smashed. So and when you release all of that, you end up with a huge noticeable imbalance because you've released a ton of pressure. So I'm just saying that, you know, the real universe, which is, there's only one universe, and it's the little tiny one, that real universe is under extreme pressure.
That requires a fresh new look on physics. Well, it doesn't look like a fresh new look. It looks like the old.
Yeah, that's the problem with his thing. He's talking about, you know, pentaquarks, neutrinos. He has all their bullshit tied up in his theory here and there, and it's like, you know, those imaginary particles that only exist for millionth of a second, and you know, when you smash things into each other, yeah, I don't think you're gonna come up with a rational theory if you're depending on those things having any function. Because there really isn't any function for them to have. The system is already kind of known. It's a charged system, plus charge, minus charge. That's what holds everything together, and the charge is in a form of a force, a plus force and a minus force.
Shamu, hi, how are you doing? He says, Muhaha, no escape, yeah. Anyways, here we have Mr. Yi, and he says, energy wave theory. Okay, Jesus, it's a very important name.
Okay, well, move on. Okay, forces. Instead of 4 distinct forces, there is one reason for a change in motion of a particle to minimize amplitude. Forces have been unified in this theory. Yeah, well, I really don't think so when you start building pentaquarks and such. So I don't think. Let's see. Photons are directly linked to particle energy through transformation of wave type form, longitudinal waves, transverse waves. There is no wave in different forms, and energy is always conserved. Well, I don't know what that is. Blah, 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 blah. So instead of dozens of particles, yes, that's very good to get rid of dozens of particles, but again, he's accepting pentaquark as a reality. So obviously his wavicles seem to have a bunch of unnecessary, in my opinion, extra elements in there. So clearly I'd say particles, there's no 100 particles, there's just plus force, minus force. The minus force is also what photons are made out of. And then there's electrons and there's protons. And everything else is a combination of those things. That's all there is. All the matter is made of electrons and protons, and all the force is just made out of a plus force and a minus force.
Together are unified into one force with a difference in wave type and amplitude, okay? And there at the bottom is...
Okay, we'll jump ahead a little bit. So anyway. Jump to somewhere. I guess you can't jump there because it hasn't loaded the damn video. Retarded YouTube. Load the video, YouTube. I won't play it at all. Oh, YouTube, you are such a cunt. Alright, it's going to force me to reload. Well, we won't bother. We'll just play a little bit of this other guy and call it a day. Alright. Sorry, the image. Okay, I'll make it full screen, see what happens.
There's no way classical optics gives you that.
I don't need this.
And so if the one slit is covered, you get a uniform distribution of dots.
Okay.
If both slit...
Isn't that just classic? I mean, it's classic bullshit. I mean, later he's going to talk about a single slit. But this is the classic crap. Now, earlier he pointed out how the slits have to be much smaller than the impediment in the middle. And so he's pointing out how they're very small slits. And clearly, they have to be big enough to let enough light through to see the pattern, so they can't be that small, actually. And it's a fact that single slits that size create a lot of pattern, lots of bars. The bigger you make the opening, the more bars you'll get. So this whole notion that you just get a blending of, just get a bunch of, soft little blend, no lines, no interference. And he's just saying it again. And he's a professional making an insipid mistake. I mean, it shouldn't even be accepted that this is a mistake. This is something more than just a mistake. I mean, how could you not understand that Newton discovered Newton's rings, and how did he do it with a small aperture? Then you had Heisenberg, who pointed out the whole reason why this is happening is somehow because by narrowing the slit, you're learning too much about the photon. You're learning too much position information by making the slit smaller, and so the god of quantum has to stop you from gaining information, so he's going to make the photon go somewhere stupid just because you were learning too much about him. I mean, all of that crap was discussed with Einstein, all that stuff back in the 20s and 30s. So how can you make a mistake this egregious, in my opinion? Just nonsense. You cover one of the slits, no pattern. No, that's just not the truth. It's complete crap. But it's used to pretend that this two-slit model is the model. And it's just one version of an experiment. So again, they're just quote mining the evidence and distorting it Okay, so they're not only quote mining, grabbing this experiment because this one works the best, but they're perverting it, they're changing it, they're adulterating it to make it fit better. They're cheating badly. And I'm just saying, how can anybody defend this? These are all professional, highly paid physicists. And I have to point out, that's just not frickin' true, buddy.
To get this kind of a distribution. Wow. Okay, now I'm going to ask you to vote on this. We do the experiment, and I've sort of given away the answer, but I still want you to vote on this.
Yeah, I read this part as text. I mean, it's actually, you get through these videos a lot faster if you just read the transcripts.
What are the possible things? So, we know there's only one photon in the apparatus at a time. Our concept of interference is light interfering with itself, and this is a possibility that said, well, I think I know. And here's another weak.
Right. Light interacting with itself, but as he was starting off the conversation, he was implying that somehow multiple photons are interfering. But yes, so the real explanation is, well, how can you have it both ways? How can you have one photon converted into some kind of mechanism that makes interference possible, and then say, but when the circumstances we need it to work, we'll just say any photon can do it any time with any other photon, this interfering thing, like in the radar experiment, for example. There's no mechanism Heisenberging the radar. There's no mechanism forcing the photon to gain a wave function. They're just regular photons going through, coming out of two different emitters. They're clearly not the same photon interfering with itself. And so there's just no consistency in this theory at all. It is that bad. And yet they cling to it desperately. When it's that broken. Its principles have no, they don't mean anything because they just violate the principle any time. Like he just violated the principle of single slit diffraction. And again, if somebody talks about the Michelson-Morley experiment, and I'll just keep pointing out the half-silvered mirror, how can anybody have the expectation that the half-silvering on the mirror doesn't create a bunch of tiny apertures and that those tiny apertures will diffract the light? How can they not know that that's exactly what's going to happen?
Interference on top of constant background.
So I don't even know why I brought up this weak interference. Where's the example of that? I don't even know what that even means.
This would reflect...
of course, and they always never talk about the envelope problem. The fact that the true double slit experiment done correctly has two patterns in it. And they have nothing. They have no explanation. Because it doesn't match water.
So we decided that we would have one photon in the apparatus. Occasionally there are two. And when there's two, there could be interference. And so we'd have some weak interference superposed on...
Well, it would have to be like 90% of the photons somehow. So that doesn't even make any sense. We don't see weak interference. We either see it or we don't see it. There's no weak interference. There's no, let's turn the interference off a little bit. So, especially in the two-slit experiment. The only place you might see some of that is in electrons. There's an awful lot of background noise in electron experiments, but the electrons do create a beautifully, the pattern is much smoother, indicating that electrons hitting electrons go around each other, they deflect, they don't hit and bounce, they curve to avoid each other.
uh, constant background.
So this part, I'd say, was, I read it and I said, boy, that all sounds quite incoherent. And I can see he's just writing a bunch of nothing.
Now we get this 100% modulated interference structure, and the last thing is something else.
100% wouldn't even be modulated.
So, now, you have to transport yourself back in time to around 1910.
So and the good thing about this is the idea that you just use the word modulated, right? So some of these conversations are good. Is that something that was sort of left out of the conversation about the radar experiment? You know, and the fact that they modulate they amplitude modulate by putting a sound signal on. And I didn't really point out that they don't modulate the whole signal. They don't turn it on and off, technically. They just modulate half of it. And that might be another reason why there's this 4-time change when you increase the amplitude. Because you're now going to demodulate. You're going to now get rid of that half mark and turn what was the positive signal into the whole signal. So in a sense, you're getting rid of the fact that your carrier was still, half your carrier was perfectly intact in terms of its amplitude. It wasn't modulated. Only half the carrier is modulated, half the amplitude of the carrier. And so when you double them, what essentially the receiver is going to do, it's just going to count the modulated part, and it's going to synthesize the bottom half, and it's going to synthesize it as modulated. That's the doubling of that's the second doubling of the amplitude, is the demodulation. Demodulation creates a bigger amplitude in the signal. It amplifies the signal.
You haven't heard this lecture, but you do know what the experiment is. And so, what would you expect? First, no interference? Raise your hand. I got one, two. I've got a few votes for no interference.
You just drew it on the board.
In 1910, that's what you would have said. Weak interference on top of constant background.
Yeah, I don't think anybody would be dumb enough to pick that one. I don't know. He's asking people to what? Either imagine you're back in 1910 or to imagine you just saw him say it creates 2 bars. You know. You already gave the answer, so why have we bothered asking a question after you already gave the answer?
Well, that would be what you're hedging your bets and saying, well, the experiment isn't perfect, and this is really the right answer, but if someone was a little sloppy, I'd get this.
I don't know how they could do that. I don't even know how they could sloppily get that. So, yeah, no, I don't think so.
Raise your hands. For this one, what would you have said in 1910?
I don't know. I can't read it, so I don't know what the fuck it is. 100% modulated? Oh, that means 100% interference. Oh, okay. Damn. I mean, that's what it means. It means 100% interference. 100% constructive and destructive interpercent. 50% destructive, 50% constructive.
I got nobody with the courage to say this. You would have gotten a Nobel Prize if you could have defended it. Something else. Well, maybe something else. Maybe the photons come in pairs. Or something ridiculous.
Right, exactly. So they're just making it up. And he even admits this somewhere. He says this is, just stuff, I can't remember the word he uses, but, and these are the guys who are doing it, right? So this guy doesn't really impress me as somebody who's necessarily cautious or careful or, they're just making, here's a problem, let's blame it on something. And gremlins, cooties, gummy bears, let's just blame it on something. Let's scapegoat something as the cause. And so they just scapegoat. Oh, it's a multiverse did it. The dark energy did it.
So, the correct answer is 100% modulated. What people would have said...
Yes, they wouldn't have used the word 100% modulated because it doesn't really suit the circumstances I just pointed out. You wouldn't make it on-off. It's not a modulated anything. That's not modulating. That's segregating. Word I would use. Or you just call it interference. So that's how, they just make, I bet he confused half the class by doing this crap of saying no interference and 100% modulated, which is interference versus no interference. The 100% modulated means interference. I don't know, so I have no idea why he did it that way.
10 is this. Some curmudgeons, like the climate change deniers would have said, well, there's a little bit of this or maybe that, but I can't possibly accept that, which is the truth.
So implying that you have to be crazy not to believe in this idiotic notion that photons split in two and create wave functions and interfere with each other, except when they're in the interferometer, because then it's different photons, or except when they're radar, because then it's different photons, and but no, the photons really don't do that. If I shoot laser beams, I can shoot laser beams all day long and I ain't going to get anywhere. I can reflect them off metal right at the same spot, and I can't mix them. I can't do anything to get these. Somehow the force will never do this interference thing in the real world. But, oh yeah, these little special circumstances, I can make photons do all kinds of wacky crap. Again, they give all of the power to the photon and don't pay any attention to the physical devices they're using to interfere with it. So they're blaming the interference on the function of a photon, when the interference is clearly being caused by the mechanism, the slits in the light experiment. And as I pointed out, it doesn't even exist in the radar experiment. There's no interference at all. There's just jamming a signal. You can't receive a signal that's on top of another signal of the same frequency. You just can't do it. The receiver can't tell left-hand frequency from right-hand frequency. It can't tell the radio station that hit it from this side from the radio station that hit it from this side. It can't see. It can't separate them. All it sees, all it coming to once it hits the antenna makes it into this. And when this goes to the receiver says, what the fuck is this? I can't do anything with that. And that's what's causing the pattern. It's the obvious answer. I think it's obvious to anyone who just... I can't believe you're all this dumb not to see. That's exactly what happens. The energy that comes out of the antenna is just a blueprint of what went into the... It's not a blueprint. It's just a copy. It's just a transformation of what went into the antenna. And if this goes in and this goes in, there's just no hope for the antenna to do anything with it. Obviously, if it goes in this way, there's some hope. Okay? Because then it's going to do this thing. It's just going to make a bigger signal like this. It's going to make a louder, thicker, more substantial this. But if this goes in, it's got nothing. It's got no hope. I don't know how anyone could, at the minimum, any reasonable person should say, well, that does sound like a possible answer. Now, it might be possible, but I don't think it's true because these other guys really know what they're talking about somehow, and they're pretty sure there's some other explanation. But yes, that is I'll concede it's a possible explanation. People won't even do that. They're so obnoxious to this inquiry. They have decided that the truth has already been discovered. Okay, and we don't need to rewrite any of the books. The bent space is perfectly fine. The dark matter's fine. All the woo and the mush, particle wave duality. Oh no, that's true. We must have it. We must cherish that non-answer. We need to, yes, the virtual photon. No, we don't need any more resolution. We don't need to see any more. That's more than enough. We have more than enough an answer for attraction and repulsion in magnetism by just saying the word virtual photon. There, we have completed the picture of a magnet. We don't need to do any more looking, searching, hunting finding. And that's the attitude of most of you fucktards. And it shocks me. I mean, it's depressing and annoying and frustrating. But I am truly shocked. Because I don't know how you cannot see how obviously flawed this mush they've made up is and not be eating your own poo. I mean, how can you miss how bad this is and figure out not to eat your own poo? Because this is so bad as science. It is such crap. Their evidence is crap. Again, they can't describe. He couldn't accurately describe one of the simplest experiment you can just about make. Look, I made a hole and I'm going to put stuff through it. He couldn't accurately describe an experiment that fucking simple. And you sit there and, oh yeah, way to go, fatty. Sorry, it's a cheap shot, but what a pile of crap. Nice enough guy, but it's just horseshit. So anyway, I think that's enough of a video.
Okay, well, we won't belabor that anymore.
Yes, we've finished the job. We've explained physics now with nothing. Vacuous mush. Alright, so anyway, this probably should have worked. Let's see if I can get out of this full screen shit. Yes, I asked you to exit. I hit the button.
This means that...
I mean, I double-clicked. That should have been enough. You shouldn't have to ask me. Alright, anyway, so this seemed to have worked reasonably well. The drawing's a little bit grainy, but it's big. Yeah, big. Graph physics. We'll put it on a slant. Yeah, that makes it cooler, for sure. Alright, so I think that's enough of a video. So, till the next time, I still haven't really... I'd really like to use this pause feature. You know, say some stuff, then pause, go for a walk, come back, do some more. I just haven't found a way to do that yet. So anyway, till the next time and such. Alright, I used the pause feature. Just, I know I didn't move anything. I should have moved something, so then you know I used the pause feature. But I did use it. Just to prove I can.